Quantum mechanics. The classical theory successfully explained the behavior of an object that is visible to human eye, but it fails to explain the behavior of atomic particles such as electrons. It fails to explain the new discoveries like blackbody radiation, photoelectric effect, Compton effect, etc. In order to explain the spectrum produced by the blackbody, Max Planck proposed a new theory, and it is called the quantum theory of radiation. Quantum mechanics is the science of microscopic world. To predict the events in molecular, atomic and nuclear domains, we need quantum mechanics. Quantum mechanics rests on wave nature of matter proposed by de Broglie, that is matter waves. That is matter waves or de Broglie waves. Matter waves or de Broglie waves. According to Louis de Broglie, a moving particle is associated with a wave nature, and the wavelength is given by lambda equal to h by mv or h by p. Here p is the momentum and h is the Planck's constant. And the other relations are, we know that lambda equal to h divided by root of 2me or h divided by root of 2mev, where E is the kinetic energy of the particle and capital V is the potential, m is the mass, E is the charge of electron and P is the momentum. So these are the relations of wavelength, lambda equal to h by p or h by mv. Here v is the velocity and h divided by root of 2me, capital E is the kinetic energy, m is the mass, and which is equal to h by root of 2mev, where capital V is the potential. So this is matter wave relation. And wave function psi. Wave function psi. In a wave, there is something that varies periodically. For example, in water waves, the quantity that varies periodically is the height of the water surface. In sound waves, the varying quantity is the pressure. In light waves, the electric and magnetic fields vary. The quantity whose variations make up the matter waves is called the wave function. So, the wave function is a mathematical function which describes the state of the particle. And the wave function psi is a function of position and time. That is, psi is a function of both position x and time t. And it is a complex function. It is a complex function. It contains all the information that can be obtained about the system. And the wave function of the particle with energy E and momentum P can be represented as psi equal to A e raised to I by h cut into Px minus Et. So, this is the wave function of the particle with energy E and momentum. So, this is wave function. And the probability interpretation of psi or the normalization condition. We know that psi is a complex quantity. So, psi itself has no physical significance. But the quantity psi star psi, which is equal to mod psi square, it represents the probability density. That is, psi star psi represents the probability density. That is, the probability of finding the particle in unit volume. If a particle exists in a given region d tau and d tau equal to dx, dy and dz, then the total probability of finding the particle in that region is 1. That is, the total probability minus infinity to plus infinity mod psi square d tau equal to 1. That is integral minus infinity to plus infinity. We know that mod psi square equal to psi star psi and d tau is dx dy dz, which is equal to 1. That is, d tau is the volume element and this equation is called the normalized wave function, and the normalization condition is this, that is minus infinity to plus infinity psi star psi dx dy dz equal to 1. And the characteristics of wave function. Characteristics of psi. First one, psi can be normalized. Psi can be normalized. That is, psi must satisfy this normalization condition. And the second one is psi is a complex quantity. Psi is a complex quantity. We know that psi equal to a e raised to I by h cross px minus et. That is, psi is a complex quantity. And the third one is psi must be finite. Psi must be finite and psi must be continuous and single valued. Psi must be single valued. Psi must be single valued because psi is a probability, so it takes either 0 or 1. That is, psi must be single valued. And psi must be continuous. Psi must be continuous. That is, if psi is continuous, then the first derivatives dou psi by dou x and dou psi by dou y and dou psi by dou z is continuous. If psi is continuous, then these first derivatives are continuous. That is, this dou psi by dou x and dou psi by dou y and dou psi by dou z represents the momentum. That is, if psi is continuous, then the momentum is continuous. And the term dou psi by dou t is also continuous. That is, it represents the energy. So, psi must be continuous. If psi is continuous, then momentum is continuous and energy is continuous. So, these are the characteristics of the wave function psi.